So my name is Joshua Burgin, and I'm here to walk you through the last 25 years of hardware and software abstractions. And I'm going to paint a little bit of predictions, I think, about kind of the next decade. So the good news is, Ani medaber katsat ivrit. So the good news is I can continue the rest of this in English. Is okay? Good. So first, a little bit about me. But as I said, my name is Joshua. I started my career, actually was a philosophy major in college because I like studying and learning and being able to point out bad reasoning. It's turned out to work out, I think, pretty well over the time. But I kind of went back to my first love of computers with my first job working at a small internet bookstore called Amazon, which you've probably not heard of. No, they didn't make it. So it was very sad. But I worked at Amazon for 3 years. I left and I went to a bunch of startups that all failed in spectacular fashions. None of them made it big. Nobody made any money. And then I went back to AWS after a short stint at Zynga, back to Amazon, and this time at AWS. And I spent 8 years there before joining VMware last year in the Tanzu Kubernetes division. So that's my background a little bit. Not my first time in Israel. First time back since the pandemic, though, so it's great to see everybody again. So let's just kind of take a step back when I think about hardware and software abstractions. This is me. No, this is not me. I'm not that old. So this is the ARPANET, right? The predecessor to the internet. It's kind of one of the first distributed systems in technology. And so it had the concept of being able to remove a single node if one of the other ones went down and kind of route around things. This was very novel at the time, right? So the concept of being able to remove that single point of failure, that is the core nugget, the core essence of what a distributed system is even today. Then we're going to flash forward a little bit to 1985 here and then 1989. Right? This is when commercial internet access was offered for the first time. And so we've had more innovation kind of in the 20 years since then than any time in previous history in technology. Again, it still wasn't until 1993 when the first web browser was available and publicly released. So I want to ask you to kind of think about, why has there been more innovation in the last 20 years? What are the abstractions that are leading this to make it possible? Like, why is technology sped up? So I mentioned that I worked at Amazon. I worked there twice. I was actually the 42nd employee of Amazon when we all fit in one building, actually in one floor, in a place called Seattle. Anybody ever been to Seattle? It's good? Okay. Hello. So when I got to Amazon, not only did we fit on a single floor of a building, we fit on a single server. This is like a crazy idea, right? So we had a single server. We had a monolithic C binary application that was named after this city in Brazil on the Amazon River. How did we move things from QA to production? I'm not going to let you guess. We actually had 2 directories in the file system, one called online, one called offline. And then we just flipped a symlink back and forth between them. So a little bit of testing, not a distributed system. And you can kind of guess what the bottlenecks are when you have something like this, right? You have this monolithic C binary. You have the presentation layer, the data layer. You have all of the business logic wrapped up into one. You had to be an expert at networking, at databases, at HTML. You had to be an expert in using CVS. Anybody remember CVS before Git? Okay, thank you. We actually used CVS at Amazon, not just for version control, but I built a content management system on top of it. It's embarrassing now, but at the time it was innovative. So then Amazon grows, and this is going to happen again and again kind of through history here. So in 1998, Amazon has to introduce a couple new products. They move beyond books, they launch music and video, and we outgrew the biggest DEC Alpha server that we had, the biggest one that they made. It was a full rack. And so we had to build Amazon's first distributed system. And this is going to sound laughable today, right? But we went from 1 server, right? One server, to 4, right? It's like 4 times as big. So I'm really good at math. So we had 4 servers, but now we have this problem. How do you kind of take this monolithic binary? How do you distribute it? How do you do testing? And so what I built, along with a couple of other people, was developer. It'll sound just like today. We built developer sandboxes. You could promote it to what we called the customer service environment. where it looked like production, connected to the production database. And then it pushed it out to the fleet of front-end servers. We had the notion of atomic deployments, of rollbacks. We didn't have other things, though, like observability. There's no such thing as a service mesh. There were just physical switches and routers. And so it's very similar today. This is still running on bare metal machines, but this kind of abstraction is what keeps getting kind of invented time and again. So a fun story, I think our previous presenter talked about owning your failures, and maybe this will sound familiar to you even today. I pushed a bad configuration file, which the Apache web server picked up, and then it bricked all the front-end web servers. Like it locked them up so hard that you had to physically reboot them to get them to come back online. And for the first couple hours of this outage, when Amazon is down, the whole website, I couldn't pinpoint. Like, I was like, I don't know what's happening here, right? Why would these machines? Because they sort of locked up kind of one at a time. And it wasn't until later that I kind of traced back and looked at my steps. And I'm like, oh, I pushed a configuration file. Oh, it turns out that configuration file was empty and Apache just didn't care. And then it lost connection to everything. And so I learned a lot about kind of input and output and bounds testing and so forth. It's also probably why I'm not a developer anymore. And they pushed me into management. So what I'm describing here is a distributed system. And distributed systems are hard. Why are they hard? Because you assume failure. That means things are going to fail. If things were not going to fail, you would not have complexity in the system. So when you build the distributed system, you have to think about what is the correct plan? How are things going to talk to each other? What are they going to do if one part of the system goes down? That kind of complexity hasn't gone away. Amazon at this point developed something called the Distributed Computing Manifesto. And if you Google that, they actually released a sanitized version of that paper that was written by a bunch of colleagues of mine. But they built a service-oriented architecture at Amazon on the backs of this. It actually made everything worse. So all of that complexity that I was talking about, where you had to be an expert in everything, the good news was, if something was bad, you just rolled it all back. Right? You had this one binary, you just moved it back to the state where everything was good. The early service-oriented architecture, it made grave failures and kind of website degradation almost impossible to diagnose. Now you had to be an expert in everything. So I'm going to then kind of move forward. This is all bare metal, right? This is the kind of background here. So now we have virtualization. I'm not going to spend a lot of time on this, but VMware, where I work now, they invented desktop virtualization, which was very novel at the time, right? Give you the ability to run multiple OSs on your desktop. At the time, the Wall Street Journal commented that it was freedom of choice to your desktop. But what I think the real innovation is, that was interesting, is server virtualization. So basically, simultaneously, you have ESX, you have, on the VMware side, and you have Xen on the Unix side, right? Which is hypervisor-based virtualization. And so if you're not familiar with virtualization, you're basically kind of taking a physical machine and carving it up into parts. And you're doing this with things called domains. And you have a privileged domain called DOM0, which is what manages the hypervisor, which also manages all of the unprivileged domains. The privileged domain is the only one that has access to the physical resources. And all the DOM-U, all of the unprivileged domain, that's where your kind of applications are running. This innovation is what made the cloud possible. And I would have killed for this innovation when I was working at Amazon that first time. So then, Amazon launches the cloud. Does anybody know what the first service was that Amazon launched? It's actually S3, right? It's actually the storage service. So even though we think of the cloud, right, as the Elastic Compute Cloud, EC2, the first service that was launched was S3, the simple storage service. But then right after that was the Elastic Compute Cloud, which was built on the Xen hypervisor. You didn't need to know this, right, as a customer, but that's what it was running. It's not true anymore. AWS uses something called the Nitro hypervisor, which is something they built themselves, and they moved all of that kind of privileged compute onto what's called the Nitro controller, which is actually built by a company right here in Israel, in Haifa, called Annapurna, something that Amazon bought. It wasn't even until 2009 that Amazon introduced VPC, the Virtual Private Cloud, which is kind of isolated private network. Before that, everything was just in one flat network. And then there was the relational database service and so forth. So at this point, the underlying conditions become ripe for taking this concept of a distributed system and building it in an elastic fashion. But that's not enough, right? You actually need a commercial use for that. Remember the military, they had the need for ARPANET and invented the internet. These web scale companies started evolving. Netflix, Yelp, Twitter, which was not a heavy AWS user, Google, Amazon itself. And so suddenly they found themselves with this unlimited compute resources, unlimited storage, and they were operating an elastic distributed system at scale, which actually introduces another problem. So now you don't just have a few machines. Now you don't just have a few virtual machines. You have this huge pool of machines and resources. So how do you manage them? So depending on sort of how old you are, how long you've been in the industry, you may or may not remember before containers, before Kubernetes, there was Mesos. And so this is one of the earliest modern distributed system focused on abstracting the physical data center resources kind of away from the developer. And so you had a pluggable isolation model for CPU, for memory, for GPU, modules for custom resource isolation, pluggable scheduling. And then what you can see is that things started taking off on top of this, right? You have the virtualization layer. You have the cloud on top of it. You have something for managing your different kind of pools of resources. And then you start seeing things like Hadoop and Spark and Kafka, built on top of this, right? Because you've made it easier and easier to develop a system at scale. This was adopted at Twitter. Twitter was a big contributor to Mesos. Then we kind of flash forward a little bit, and you've kind of gone from this, few machines connected to a phone network, effectively, to the desktop, to the server, and you've gone these, kind of complex distributed systems operating at scale. What's the next step, right? OS level virtualization. So you kind of take these machines, you've carved them up into virtual machines. Now you carve them up into isolated, user processes inside these containers where you're sharing the OS. They start up faster, they spin down faster, and it's kind of the next level of efficiency. And at each of these points, right, the innovation that's kicked off out the other end is exponential. But we're really kind of doing the same thing, right? We're just abstracting away the undifferentiated heavy lifting from customers or from our users. So now we have all these microservices-based applications, but we need something to manage them. And so, into this world came Kubernetes. I mean, does this sound like familiar? Like what's happening at each time? It's the same idea, right? You hit the next order of magnitude of either computing or resources that are available to you, and you need something to orchestrate that. No matter how fine-grained you make the system, you need something to make it so that you're not managing the raw materials, right? And so the building blocks of Kubernetes help you deploy, maintain, scale applications, kind of finer scale and more extensively than you can do with VMs. But that's not enough, right? So now you have all of these primitives and you're kind of, spitting out containers and pods everywhere. And so, first at Google, then at other places, you need to manage those containers, right? So you have a control plane, and then you have the worker nodes, which is actually very similar. If you're familiar with Hadoop, it's exactly the same way it works, even before containers. And so you basically, the cloud providers, starting with Google, said, we're going to give you something to manage that. We're going to take away that layer from you, right? So we're going to manage the control plane, and you're still going to deploy your applications into the worker nodes. So, we've kind of gone one step further back. We're going to kind of, manage, deploy, help you scale those things. Obviously, other providers, we're not going to just do nothing. So Amazon introduced EKS. Before that, they also had ECS, which was non-Kubernetes-based container management service. Azure introduced AKS at the same time. There's also people who are not operating in the cloud, who are operating in multi-cloud fashion or at the edge. And so from my current employer, from VMware, we have Tanzu for multi-cloud and hybrid scenarios. And then you also have things like Rancher's lightweight distribution that's certified for operating at the edge, very small package. So, you keep pulling these layers back from people. So, right at this point in history, we're done, right? We've got everything figured out. There's no problems. Developer applications are writing themselves. Right? We're done? No, we're not done. There's tons of things left to do. So one of the biggest things is, I've mentioned this a few times, right? This is a distributed system. Distributed systems are hard. With Kubernetes etcd, it's the biggest problem because it's what all the other components push their state into, which means you can't simply restart it. It has a lot of parameters. It has some kind of bizarre behaviors and odd failure modes. And I don't actually think this is the fault of etcd. People kind of pick on it a lot. I think it's because it's a distributed system, which are inherently frustrating and inherently complex. So there's a lot of work still to do here. There's a lot of work in terms of understanding this. The next thing is service discovery and networking. Now you have all these microservices-based applications. You have thousands of them running, different teams, different companies. How do you connect them? How do you discover them? Physical networking, those kind of challenges haven't gone away. Latency that gets introduced in the physical network can actually have an impact on your application. So I don't know how deep you are in network protocols. I'm not that deep. But it's been interesting to watch the cloud providers put a lot of work into reducing tail latencies. And part of the reason is as you have these more finer and finer grained applications and microservices, those latencies have a larger impact on your application. So there's a ton of work left to do here. Then you have databases, right? Databases are, in my experience in 25 years, there's been a lot of innovation, but they feel fundamentally the same, right? They don't have the sort of fine-grained resource allocation. They don't have automated deployment. Even if you're using a managed database service from a cloud provider, behind the scenes, it's not a containerized microservices-based application. It's a super heavyweight 2 or 3 tier application. The database, and you'll know this if you go deploy a database yourself, right? I find the amount of innovation in terms of databases' ability to scale horizontally and vertically. There's graph databases. There's NoSQL databases. That's really exciting. But there's a ton of work here where you still need to be a database expert to kind of understand which purpose-built database do I use. When I left Amazon, I think there were 14. I think there's 16 or 17 different databases, managed services just from Amazon. And that's not to mention the partners and, of course, what's offered in other places. Then there's storage. This is the same comment that I just made with databases, right? You have block storage, file storage, object storage. It's more limitless these days. You have fine-grained permissioning, right, if you're thinking about role-based access control. But containerized storage is in the absolute infancy. You still have to actually know which kind of storage do I want to provision, how much of it. If I'm using block storage, I have to know which kind of volume type. What unit do I scale on? Am I performance bound, size bound, this sort of thing? Why do I have to know that, right, as a developer? The answer right now is that the storage is not really containerized. And then there's security, which I would argue containers have made significantly more complicated. And I actually think in a good way. I think everybody had fundamentally fooled themselves with security in the past. You had kind of perimeter security, right, where you just had this, maybe a dome kind of over things. And, you just assume that you keep everybody out and everything is fine. Obviously, that wasn't true, but people could persist in that belief. Now that you have this elastic microservices-based application, new services are coming online every day, you know for a fact that securing at the perimeter isn't enough, and it's probably not going to work anyway. You can't really close off all of the ports. And so you're not even actually aware. Most security tools are not aware of what's actually going on inside of a container or inside of an application running on a container. So, I know this is true. I know that this is the hardest problem because I see a ton of startups, especially here in Israel, kind of working on this problem. So these are things like all of this here. Developers still have to think about all of this, right? So we built a virtualized environment. We containerized it. We made it elastic. And at the same time, if you're building an elastic, distributed, containerized, microservices-based application, your world hasn't really gotten that much easier. Some things have, but, there's so much left to do. So, but where there are those problems, there is big opportunity. Everybody here in this audience, right? So we kind of started this journey on our connected systems. We abstracted away some of the problems from developers. Let's take that to the next level, right? Moreover, I've been talking a lot about the cloud. Did you know that somewhere between 75 and 90% of technology spending is still on-prem? So as big as the cloud providers are, AWS is $80 billion a year. Azure is somewhere around half that size. Google's like $10 billion a year. Even with all of that, that means the IT industry is somewhere between $2 and $4 trillion a year in spending. So it's not just the dollars, right? Those are millions of developers. I'm assuming that number is about right. Millions of developers building applications that they want to modernize, but they've been burned before, right? They've been burned by, kind of technological developments that every time they embrace them promise to free them from the physical world, free them from kind of the constraints of the underlying platform. So my kind of challenge for you all, right, is how do we build an application development framework that does that solves those problems on the previous slide, right? How do we make it so that people don't have to think about hardware, location, operating system, instruction set? As well, failure modes are more complex than ever. I've mentioned this a few times. Do you remember that story I said about kind of the failure mode that I induced? It was relatively simplistic. I came back to Amazon in 2014, and there was a big S3 outage. You know what it was caused by? Bad configuration file, right? Like, the same problem still today. And that service-oriented architecture, when Amazon first went to it, it was supposed to make it so that, you had a smaller surface area where you could kind of stay in your swim lane. But instead, every website outage became, get everybody on the phone because there's 10 different services at the time kind of communicating with each other. And you didn't know if it was the search service or the credit card database or the front end that was causing a problem. That's exactly what's going on today, right? All those different database types, how do you pick between them? And then when you get into things that we haven't even really talked about today, right? The composable web or WASM, I can't even imagine the complexity of kind of debugging and monitoring and scaling applications when they're distributed an order of magnitude greater than they are today. But again, the good news is we're just getting started. So I've never been more excited to be in the technology industry than today. Every few years when I feel like, okay, we've reached the end of something, there's just an explosion out the other side. And so I don't know if it's an advice or a call to action or my hope for everybody here, the reason I'm here today and the reason I keep working, is that if you go out and seize that opportunity, you can build consumer applications, business applications, platforms for developers. There's so much opportunity for you to kind of take away all of those challenges, while embracing the things that we're talking about at the same time. And so with that, I wanted to say thank you, Toda Shabbatem, and enjoy the rest of DevOps Days.